Welcome back to the Basic Electronics series, and today we will learning about field effect transistors fundamentals. And here is the agenda: FET, introduction, classification, construction, symbol, operation and working, transfer and drain characteristics, application of JFET, and MOSFET introduction, construction, symbol, types, working principle, operating region, and MOSFET acts as a switch, application, advantages and disadvantages. And next is the introduction about FET. So field effect transistors. FET is nothing but field effect transistors. These are widely used in electronic circuits for various applications like switching, amplification, filtering and oscillation. And these are classified into different types based on the structure operation. So metal oxide semiconductor FET, metal semiconductor FET, junction FET and high electron mobility transistors. So among these types, MOSFET and JFETs are the most common ones. Why? Because they offer high input impedance, low noise and relatively simple construction. Here you can see the classification. I considered only the JFET and MOSFET here. Under JFET having depletion mode, under this we having N channel and P channel. But in MOSFET we having depletion mode as well as enhancement mode. So under the depletion mode we having N channel and enhancement mode having N channel and P channel. So this is the JFET construction. So it is a semiconductor device used to control current using voltage. So it has three terminals: source, gate and drain. So source where current enters. So gate controls the current and drain where the current leaves. So this is N channel JFET. A long N-type semiconductor bar forms the main channel. So this is N channel. So at both ends metal contacts are provided. See here, one end we having source and one end we having drain. On both sides of this N bar we having P-type material. See here, this one and this one. So these P-type regions are connected together, that is called gate. So these are connected together. And current flows through the N-type channel and gate controls this flow. And in P-type JFET, just opposite to N channel. So here main channel is P-type material, side regions are N-type material. So source and drain contacts at the ends. So here current flows through the P-type channel, that is controlled by the gate. And ohmic contacts are there. So ohmic contacts means these are the metal connections placed at both ends of the semiconductor to make proper electrical connection for source and drain. So N channel JFET having electrons carry current, but P channel having holes carry current. We know, right? N means electrons, negative. P means holes, positive. So source supplies the carriers into the channel and drain collects carriers from the channel and gate controls how much current flows. So JFET is made up of semiconductor channel with source and drain at the both ends and gate on sides to control the current flow. So N channel uses electrons and P channel uses holes. So that's all about the construction. And next is the symbol of N channel and P channel JFET. So here is the diagrams that shows the symbol of two types of JFET. One is the N channel JFET and one more is the P channel JFET. So both have three terminals: gate, source and drain. So this is the n-channel JFET. Here you can see arrow direction is pointing inward toward the channel. So current mainly flows from drain to source. So electrons carry the current, gate controls the current flow. So in n-channel JFET, arrow points inside and current flows due to electrons. But in p-channel, arrow direction is pointing outward from the channel. So here current flows through holes and gate again controls the flow. So in p-channel JFET, arrow points outside and current flows due to holes. So arrow in is nothing but n-channel, arrow out is nothing but p-channel, and gate controls current, source current enters and in drain current leaves. And water analogy for the JFET control mechanism. So think of JFET like a water tap system. So here water flowing, but in JFET electric current is flowing. So source is nothing but this tap pipe. So water starts flowing from here, means current is flowing from the source. And drain is nothing but outlet or sink. Water goes out here, means current leaves in a drain. And gate is tap handle, so it controls how much water flows. So if tap handle or gate is fully open, water flows freely, means there is more current. If tap handle is partially closed, means less water flows and current decreases. If tap fully closed, means there is no current, no water. The gate does not supply current, it only controls the flow, just like a tap handle controls controls water. And next is the JFET operation and working. So we already discussed in the previous example, it is like water pipe. If pipe is open, means water flow easily. If we press the pipe, water flow reduces. So JFET works exactly like this. So pipe is nothing but channel, water is nothing but current, pressing pipe is nothing but gate voltage. So when gate voltage is 0, channel is wide and electron flow easily from source to drain. So here current is maximum. So no gate voltage means full current flow. And this is the example of saturation mode. So here you can see, and this is the example of pinch off mode. So in saturation mode, channel is narrow but still open. So current flows but becomes almost constant. So current flows steadily even if gate voltage increases. But in pinch off mode, depletion layers almost touch. Here you can see. So channel nearly closed, current becomes very small. So when reverse voltage applied, means gate forms a depletion region. Here you can see. So channel becomes narrow and current reduces. Sorry, this is not, this is saturation mode. That's all about the JFET operation, and let's see about the transfer and drain characteristics. So this is the transfer characteristics curve and this is the JFET drain characteristics. So JFET is nothing but voltage controller device. That means the gate voltage is VGS and that controls the drain current, means ID. So this is drain characteristics. This is one and the same. So here in x-axis we having VDS, drain source voltage. In y-axis we having drain current. Different curves means different gate voltage, that is nothing but VGS. Here you can see VGS. there is different VGS is there. So in linear or ohmic region, a small VDS, current increases normally. Here you can see in ohmic region current is increases. So JFET behaves like a resistor. So here current increases as voltage increases. But in saturation region or pinch off region, channel becomes narrow due to a gate voltage. So here current becomes almost same. Even if voltage increases, current stays nearly constant because the gate squeezes the channel. So this is the main working region. One more is we having cutoff region. So when VGS reaches pinch off voltage, channel closes and current becomes 0. So no channel means there is no current. So this is about the drain characteristics. And next is the transfer characteristics. In x-axis we having VGS, but in y-axis we having drain current. When VGS is 0, this is VGS. So when it is 0 means here you can see the drain current, maximum current. So when VGS becomes more negative, so this is negative, that time what will happen means current decreases. Here you can see current is decreases. So at pinch off voltage current becomes 0. So here you can see current is 0 here. So more negative gate voltage means less drain current. So this is the transfer characteristics. And next is the application of JFET. So JFET are used as an amplifier. So it is used for mixer operation of FM and TV receivers. So it can be used as voltage variable resistor, and it also used in computer memories because of small size. And next is the MOSFET. MOSFET is nothing but metal oxide silicon field effect transistor. So this is known as the MOSFET. So it is nothing but the electronic device used to switch or amplify voltages in circuit. So it is a voltage controller device and constructed by 3 terminals, that is source, gate and drain. So this is the MOSFET construction. It has 4 terminals, source, gate, drain and body. So base or substrate, this one. So the base is made up of P-type semiconductor. So this is, here we considered NPN, NMOS. So this is made up of P-type semiconductor. This is called body or substrate. So this P-type base supports the whole MOSFET structure, and this is the source. 2 heavily doped N-type regions. So these are made up of P-type base. This is N-type. So these from source means where current enters and drain means where current leaves. These two N-type areas acts as a entry and exit points for current. And here a thin layer of silicon dioxide is placed above the base. So this is placed above the base. So this layer acts as an insulator. So this layer prevents direct electrical contact with the gate. And this is the gate terminal. A thin metal plate is placed on the oxide layer. So this metal plate forms the gate terminal. So this gate will control the current without touching the semiconductor directly. So when voltage is applied, a conductive path forms between source and drain. So this path is called the channel. So gate voltage decides whether current flows or not. A voltage source is connected between source and drain. So that time gate voltage controls current flow in that circuit. So by adjusting gate voltage, we control the drain current. So MOSFET consists of p-type base with two n-type regions. So that is source and drain. So this is about the MOSFET construction. And next is the symbols of MOSFET. So the three terminals every MOSFET having, right? So that is nothing but drain, gate and source. So the gate is the controller or switch handle. Drain means where the current enters or leaves. Current leaves. And the source is nothing but the current enters. So this is the source of electrons or current. So N channel and P channel MOSFET. The direction of arrow, here you can see the direction of arrow on the middle line tells you the time. So in the N channel the arrow points in, here you can see, towards the gate. But in P channel the arrow points out, away from the gate. So we have an enhancement versus depletion mode here, isn't it? So in vertical line, here vertical line is there, right? So between the terminal tells you if the switch is normally open or normally closed. So in enhancement mode you can see the broken line here and here. So the line is dashed or has gaps. So this means the switch is normally off. So you must apply voltage to enhance it and turn it on. So this is the most common type. But in depletion mode, this solid line you can see, so it is continuous. This means switch is normally on. Here also it is there. So the channel already exists. You apply voltage to deplete it or turn it off. So this is the symbol of MOSFET. And next is MOSFET types. So there is, in enhancement mode we having P channel and N channel. In depletion mode also we having P channel and N channel. So when voltage is applied to the gate, electric field is generated. So that changes the width of the channel region. So where the electrons flow. So the wider the channel region means there is better conductivity of a device. So we have in two modes, one is the depletion mode and one more is the enhancement mode and one more is the depletion mode. So here you can see we having p-type substrate. These are the electrons flowing and we applied voltage plus 5 volt. So this is the NMOS transistor in the enhancement mode and this is the NMOS transistor in the depletion mode. So depletion mode means fully on state. So N regions means here you can see the green blocks. So this is source and this is the drain. They have lots of free electrons. So see here, this is the negative charge. So here we having p-type substrate. This is grey area you can see here. So this is the base material. It mainly has holes, means positive charge. The top metal plate is nothing but gate. So here minus 5 volt on the gate means negative voltage is applied to the gate. That blue dots here you can see, that is nothing but the electrons. So what is depletion mode? It means, so it has a channel between it already has the channel between source and drain without needing positive gate voltage. So at 0 volt it is normally on. Then we apply negative voltage like minus 5 volt, it starts turning off. So what happens in this picture means, so we has the gate has minus 5 volt. A negative gate repels the electrons away from the surface. Here it is repels. The electron channel between source and drain becomes thinner. This region under the gate becomes depleted of electrons. So current flow decreases. If the negative charge becomes strong enough, the channel disappears completely. The transistor turns off. So think of the channel like a water pipe. At 0 voltage, pipe is open, water flows. So apply negative voltage, pipe gets squeezed. But more negative voltage means pipe closes, there is no flow. So depletion mode, NMOS is normally on. Applying negative gate voltage removes electrons or depletes electrons. So this reduces current and can turn the device off. So this is about the depletion region. Here you can see this diagram shows the NMOS transistor, but with the plus 5 volt applied to the gate. So same part as before. So N region, here you can see green block, source and drain. Here many electron is there. P type means substrate, that is in grey color. So these are holes having, and gate on tap here, and plus 5 volt applied to gate. So what happens when plus 5 volt is applied? The positive gate voltage attract electrons. Here you can see electrons from N region move toward the area under the gate. So these electrons gather and form a strong channel between source and drain. So current can now flow very easily. So these blue dots here you can see, these show the electrons. Many electrons gathered under the gate, a clear path connecting between source and drain. The channel is stronger and wider than before. So positive gate voltage here we apply means it pulls electron up, build a thick channel, there is more current flows. Think of it like negative voltage means squeezes the pipe, there is less flow. Positive voltage like widen the pipe, there is more flow. In depletion mode device, so at 0 voltage already on, minus voltage turning off, and plus 5 means strongly on. So channel becomes even stronger. So gate voltage, what happens, state minus 5 channel shrinks, means turning off. 0 volt channel means that is exist on, plus 5 channel means strengthens, means strongly on. So that's all about the modes, enhancement mode and depletion mode. So operating regions, this is we already seen right in the drain characteristics. We having cutoff region, ohmic region and saturation region. So in the cutoff region there will be no conduction. So MOSFET is off. It behaves like a open switch. But in ohmic region, so current IDS increases with the increasing value of the VDS. So here when MOSFET are made to operate in this region, so this is used as the amplifiers. In the saturation region, so here you can see, I already explained, this is the saturation region. So the MOSFET have their IDS constant in spite of increasing VDS, and it occurs once VDS exceeds the value of pinch off voltage VP. So in this condition, device will act like a closed switch through which a saturated value of IDS flows. The result is operating region is chosen whenever MOSFETs are required to perform switching operation. So simply we can say that it is used in switching operation, it is acts as the amplifiers, and it behaves like an open switch. And next is MOSFET acts as a switch or MOSFET as a switch. So MOSFETs are commonly used as a switch. So this circuit shows the configuration of MOSFET when it is used as a switch. So here we having three terminals, drain, gate and source. It controls the input comes from here, that is gate. But this drain is connected to the lamp and source is connected to the ground. So this gate control the input gate controls input comes from here. So when voltage comes to gate, when voltage comes to this gate, MOSFET turns on, current flows and this lamp glows. This lamp is connected between plus VDD supply and the drain. Here you can see VDD and this is drain. When MOSFET on, circuit completes, lamp lights. So here we having flywheel diode. So it connected across the lamp. So why means it will protect MOSFET from voltage spikes usually used when load is inductive. So it safely releases stored energy. And we having input resistor RL. It limits current going to the MOSFET gate here. So it protects gate from sudden current. And we having RGS here. So this is gate source resistor, pull down resistor. So it keeps MOSFET off when no input signal. So when this Vin is high, that time gate gets voltage, MOSFET turn on and current flows. So plus VDD to lamp, MOSFET to ground. Here you can see plus VDD, lamp, this is MOSFET and ground. Current flows. So lamp glows. When Vin is low means MOSFET off. There is no current flow. So lamp off. So this circuit uses MOSFET as an electronic switch to control a lamp, and flywheel diode protects the circuit from the voltage spikes. So in enhancement mode, N-channel MOSFET is used to switch a sample lamp on and off. The input fade voltage VGS is adjusted to an appropriate positive voltage to switch on the device, and the voltage level is set to a negative value or 0 to turn it off. The switching characteristics for both N-channel and P-channel type MOSFETs are summarized in the below table. Here you can see in N-channels, in depletion mode it is VGS is off, VGS greater than 0 means it is off, VGS equals to 0 means it is off. So when VGS greater than 0, this is VGS VGS, here VGS is greater, but here VGS is lesser than 0. That time off. When VGS is equals to, that time also off. When VGS greater than 0, that time on. But in depletion mode, so when VGS is less than 0, that time only off. Rest all time it will on. P-channel enhancement, it will on when VGS is less than 0, and it will off when VGS equals to 0 or VGS greater than 0. But P-channel depletion, it will on in both conditions, when VGS is less than 0 and equals to 0. It will off when VGS greater than 0. And application advantages and disadvantages. So MOSFETs are used in radio frequency applications. So it amplifies extensively. So it is used in radio frequency applications. So it behaves as a passive circuit element. And power MOSFETs can be used to regulate DC motors, and these are used in design of the chopper circuit. So why MOSFET is used in this? Because it has some advantages. So MOSFET operate at greater efficiency at lower voltages. So absence of gate current results in high input impedance, producing high switching speed. So it also having disadvantage. So MOSFETs are vulnerable to damage by electrostatic charges. So due to the thin oxide layer, and it overload voltages, so this makes the MOSFET unstable. So that's all about the field effect transistor. For more classes, please watch the upcoming videos. Thank you all.